Good afternoon, everybody. What we are going to do today, I'm going to take you through the homework, the classwork that we had yesterday while I was out. There were 10 questions that were kind of as review for Thursday's quiz. So I'm going to go through those questions, and if you have any questions at all about them, if you looked back on your classwork and there were some questions you got wrong and you're not sure why, this is the right video to watch. Okay, so I'm just going to start with number one. I'm going to go through these, and then, at the end, if you still have a question about one of these questions, just send me a chat, send me a message on Schoology, and just let me know. Okay. It would all be a good idea that while you're watching this, have your classwork from yesterday up on the split screen so that you can check over your work while I'm kind of going over and explaining this work here. Okay, so the first question, this one was actually keyed wrong and I feel really, really bad. So it told you that the right answer was incorrect and one of the wrong answers was the right one. So I fixed that right now, but I would definitely go back and double check. And if you were confused on why you got it wrong the first time, well, you might have gotten it right. And I'm sorry about that. Okay. So our first question, the diagram represents the lines of latitude and longitude on Earth. Points A through E represent locations on Earth. So here is our globe. We have points A through E. The question is, from which location would an observer never see Polaris in the nighttime sky? So keyword here is never. When would we never see Polaris? Ever, 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 never. So if you remember about Polaris, it's called the North Star, and Polaris is only visible in the northern hemisphere. So any place north of the equator will be able to see Polaris. So that means if you're south of the equator, you're not going to see Polaris. Polaris is only visible in the northern hemisphere. So only from the North Pole down to the equator here can you see Polaris. Which means if you're below this bold line here, this is the southern hemisphere. So any point below this bold line, which is the equator, you're not going to see Polaris. And if we look on this diagram, those two locations are location D and location E. If you're at either of those two locations, you will never see Polaris. You are in the southern hemisphere, you cannot see it. So if we look at our answer choices, A, B, and C, they are all in the northern hemisphere, so they will be able to see Polaris. Location D, southern hemisphere, you cannot see Polaris. So our answer here for question 1 is D. Question 2, same diagram. The diagram represents the lines of latitude and longitude on Earth. Points A through E represent locations on the Earth. Which two locations are in the same time zone? So here we have 3 options. There were 4 options. One of them got cut off in this picture. I'm not sure what happened there. But we have A and B, B and D, and C and E. So which one of these 3 options will we be in the same time zone? Now, if you remember, time zones are determined by longitude. They are determined by longitude. So if you are at a location with the same longitude as another location, you will have the same time zone. Okay? It doesn't matter how close they are together. What matters is their longitude. So A and B here, they're very close together, but they are on different lines of longitude. Okay? Even though they're so close together, because they're on different lines of longitude, they will have different times. It might not be off by much. And if we look here, this is 90 and this is 75. So they're going to be off by 1 time zone, which is 1 hour. But they're not going to be in the same time zone. They are off by 1 time zone. However, B and D, you can follow this line of longitude all the way down. B and D are on the same line of longitude. So B and D are in the same time zone. So B and D will be our answer here. Okay. C and E, they are not on the same longitude. They're not even on the same latitude. They're very far away from each other. These two have almost nothing in common. But B and D, they're on the same line of longitude, so they have the same time. Question 3. On the image below, identify the star known as Polaris. And I gave you, I think, 6 options here. Which one of these stars is Polaris? Okay, so just remember, these lines here that we see all over the place, these are called star trails. Okay, and a star trail is the path that a star takes throughout the night based on the rotation of the Earth. So it looks like these stars are moving throughout the night. They're not actually moving, but they look like they're moving. Okay? The one star in the night that doesn't move, that stays in the same place in the night sky all night, is the star here in the middle. And this star here in the middle is Polaris. So if you ever see a star trail map and asks which one of these stars is Polaris, it will always be the star in the middle. Question 4. The map below shows 4 major time zones in the United States. The dashed lines represent meridians, or lines, meridians just a fancy word for lines, of longitude. The locations of New York City and Denver are shown. So here we have New York City, here we have Denver. What is the time in New York City when it is noon in Denver? Now remember, noon is 12 p.m. So if it is 12 p.m. in Denver, what time is it in New York City? Now remember, the way we remember time zones is our acronym WHEEL. West early, east late. And what that means is that if you go to the west, it will become earlier in the day. And if you go to the east, it will become later in the day. So if we go 1 time zone to the west, it's going to be 1 hour earlier. So if we go to the Pacific time zone, it's going to be 11 a.m. And if we go to the east, if we go 1 time zone to the east, it will be 1 hour later. It will now be 1 p.m. Okay, New York City is 1 more time zone away. So if we go 1 more time zone, New York City is over here. If it is 1 p.m. in the central, that will make it 2 p.m. in the east. So our answer here is 2 p.m. Question 6? I'm not sure. Lost track of time. The map below shows a portion of the Earth system of latitude and longitude and 5 surface locations labeled A, B, C, D, and X. If it is noon at location X, which location will solar noon occur next? Now we can use our same acronym as we used last question. We can still use WHEEL. West is earlier, east is later. So if we were to look at our compass here, north, east, south, and west, if we go this way, it's already later in the day, right? So this is noon, so this will be afternoon. It's already later in the day. Noon has already passed going west. If we go east, it's going to be earlier in the day. So here it's going to be morning still, right? It's not noon yet. It will still be morning. Okay. Remember that time zones are determined by our lines of longitude. So even though A is much closer to X than B is, because B is on a closer line of longitude, our answer here will be B. Question 7, 8, 9, 10, 11. Okay. This is question 6. The diagram below shows an observer on Earth viewing the star Polaris. What is the observer's latitude? Now remember, the thing we need to remember about this is that the altitude of Polaris is equal to the observer's latitude. Okay. No fancy numbers, no fancy math, no fancy formulas, nothing like that. They are exactly the same number. So the altitude of Polaris here is 52. So our latitude will be 52 degrees. This gets us halfway there. So it's not going to be this, it's not going to be this. But we have two answers that say 52. Remember, from that first question, Polaris can only be seen in the northern hemisphere. Polaris can only be seen in the northern hemisphere. NH for northern hemisphere. So that means it can't be 52 south because you cannot see Polaris at 52 south. So it must be 52 north. Next question. Another map. Base your answer on the world map below. Letters A through D represent locations on the Earth's surface. At which location could an observer not see Polaris in the night sky at any time of the year? So here we have A, B, C, and D. Remember, from question 1 and the previous question, you cannot see Polaris in the southern hemisphere. So we need to find a location that is below the equator, and that will be where we cannot find Polaris. So our equator is right here at 0 degrees. So any location that is below this line here that I'm dashing out, you will not be able to see Polaris. And if we look here, there's only one answer that is below that line, and that answer will be B. Location A and D are north of the equator, so we can see them. We can see Polaris from those locations. Location C is right on the equator. You can still see Polaris on the equator. It'll just be very low in the sky. Okay. Location B, can't see Polaris at all. So our answer here is B. Question 9. Question 8. The diagram below shows an observer on Earth measuring the altitude of Polaris. What is the latitude of the observer? Again, let's remember that our altitude of Polaris equals the latitude of the observer Okay. So now we have two angles here. We have 23.5 and 66.5. Remember that altitude equals the angle above the horizon. So our angle above the horizon, rising from the horizon, is going to be this angle here, and it will be 66.5. This is what we call a distractor answer. It looks good, and a lot of people pick it. This is never the right answer. Our angle of Polaris and our latitude will always be this lower angle here. Okay, almost done. Question 9. The diagram below represents the Earth's latitude and longitude system. Here we have our prime meridian. Here we have our equator. Go this direction, we're going north. Go this direction, we're going south. Go this direction, we're going east. And go this direction, we're going west. So here is location L. What is the latitude and longitude of point L? So the way we determine latitude and longitude, we start from the equator and we go up or down to our point. Our point is down, so we're moving south. So our latitude is going to be something degrees south. We find this point here, We go over to our axis. It ends up being right about there. We have 0, we have 10, halfway between will be 5 degrees south. Okay. Already looking now, we have 5 degrees east, 5 degrees west, 5 degrees north. There's only one answer left, but let's check that. Okay. Next thing we do is we go from our point, from our prime meridian. So we go over from the prime meridian. We have gone west, so we will be going degrees west. And if we go up, we are right here at 30 degrees west. And if we look at our remaining answer, 5 degrees north, 30 degrees west. Cool. All right. And our very last question. The diagram represents the lines of latitude and longitude on the Earth. Points A through E represent locations on Earth. Which point has a latitude and longitude of 40 degrees north, 75 degrees west? This is almost the opposite of what we did last time. Last time I gave you a point and you had to tell me the latitude and longitude. This time I tell you the latitude and longitude, you have to give me the point. So first things first is we go north of the equator 40 degrees. So here's our equator. We go north, so we're going up 20, 40. So our answer is going to be somewhere on this line here. Okay, we have two options on that line. We do not have D, we do not have C, we do not have E, but A and B are both on those lines. Next, what we do is we find 75 degrees west. So now we go from our prime meridian and we go 75 degrees to the west. Remember, north, south, east, and west. So west is going to be going to the left. 15, 30, 45, 60, 75. And now we go up from there. And what is our value? Where both 40 and 75 intersect, our answer is going to be B. Okay, well, I hope that was helpful. I believe that is all of the questions, and it is. If you have any questions at all, please send me a message, send me something in the chat, and I'll try to clear things up for you. Okay, have a great day, and I will talk to you soon.